In today's class, we are going to see a problem on two-dimensional random variable of continuous type. So the problem, a data scientist studies customers' interaction patterns on an e-commerce platform. So here you have two variables, x and y. So here x denotes the time spent viewing recommended products and y it denotes the time spent in reading product reviews. So these two are your random variables. You are also given the joint probability density function of x and y. So the joint probability density function of x and y is f of x comma y is equal to k into x plus y. Okay, so this is the given joint probability density function, and also you are told that your x varies from 0 to 1, likewise your y varies from 0 to 2, and it is equal to 0 otherwise. So only in this range your probability density function is given by this equation. Apart from this limits, your f of x comma y is 0. So what you are asked to find is, you are asked to find the value of k. Next you are asked to find the marginal probability density function. So for x and y you will find what the marginal probability density function is. Then you will find the conditional density function of y given x is equal to half. So you will find the conditional density function of y. Likewise, you will find the conditional density function of x given y is equal to 1. Finally, you will check whether x and y are independent. So for this problem, we have 5 subdivisions to be found. Okay, the first one, we have to find the value of k. So since it is a two-dimensional random variable, so we know that the probability density function, it satisfies double integral over f of x comma y is into dx dy is equal to 1. Okay, so this is the condition for your satisfied by the probability density function. Okay, so here we have two limits. Our f of x comma y value is nothing but k into x plus y. Okay, dx dy. So the x limits, your x varies from 0 to 1. Okay, so your x varies from 0 to 1. This is the limits for your x, and your y varies from 0 to 2. So this is the limit for your y. So now we have to do normal integration and we have to equate it to 1. Okay, so now we are going to integrate it. We are going to do the integration first inside. Okay, so the outer limit will stay as it is. K is a constant that can be taken outside. Okay, now the limit 0 to 1, you have x plus y into dx. So integral of x with respect to x is x square by 2, and the next term you have y. So integration of y with respect to x. So y will be treated as a constant when you are integrating with respect to x. So integral of y would be y into x. So now we have done the integration with respect to x. So after this you have to apply the limits. Okay, so now you have the outer dy and it should be equated to 1. Okay, next k into 0 to 2, substituting the limits in the place of x. So it is 1 by 2 plus y. Substituting the lower limit, both the terms will become 0. So this thing into dy is equal to 1. Now next what you have to do is, you have to do the inner integration. So integration of 1 by 2 with respect to y is nothing but 1 by 2y. For the second term it is y square by 2. Okay, so now apply the limits and equate it to 1. So now k will be, instead of y you will substitute 2. So 2 by 2 plus 4 by 2. Substituting the lower limit, everything will become 0. Okay, so it will be k into 1 plus 2 which is equal to 1, or k will be equal to, or k into 3 is equal to 1, which implies the value of k is nothing but 1 by 3. Okay, so first we have to find the value of k. So the value of k is 1 by 3. Okay, so first we are going to find the probability density function of x. So f x of x should be found. Okay, so f x of x is nothing but integral over f of x comma y with respect to y. Your integration should be done with respect to y. So which is equal to, your f of x comma y is nothing but k into x plus y into dy. The limits for your y is nothing but from 0 to 2. Okay, so this would be equal to 0 to 2. K value is nothing but 1 by 3 into x plus y into dy. So 1 by 3 is a constant that can be taken outside. So 1 by 3 into integral of x is nothing but, x is a constant when it is integrated with respect to y. So you will have x y plus y square by 2, and the limit would be from 0 to 2. Okay, so which will be equal to 1 by 3 into, in the place of y you have to substitute the limit. So it is 2x plus 4 by 2. So these two things will get cancelled. the lower limit it will become 0. So 1 by 3 into 2x plus 2. Okay, so this is your marginal probability density function of x. Okay, so next one, probability density function of y. So when you're finding y, you have to integrate your f of x comma y with respect to x. So your x limit varies from 0 to 1. Okay, so for x, it is k into x plus y into dx, where your limit varies from 0 to 1. Okay, so which will be equal to k value is nothing but 1 by 3. It is a constant, it can be taken outside. Integral of x is nothing but x square by 2, and for y it is x into y. After you integrate, you will apply the limits. So it is 1 by 3 into 1 by 2 plus xy. So you will have, instead of x you will substitute 1. So it will be 1 by 2 plus y. Okay, so this is the value of your x, marginal probability density of x, and this is the marginal probability density of your y. So we found the marginal probability density of x and y. So this is your marginal probability density of x and y. Next, what you have to find is, you have to find the conditional density function of y given x is equal to half. That is your third subdivision. So third subdivision, you have to find the conditional density. So what you have to prove for conditional density is, you have to find the probability function of y given x is equal to half. Okay, so this is nothing but f of x comma y divided by f of x is equal to half. Okay, this is how you write the conditional density function of y given x. Okay, so obviously we know that f of x comma y is the probability density function which is given in the question. Your denominator x is equal to half means this is the marginal density function. Okay, f of x for x is equal to half. So you have to substitute the value of x is equal to half in this equation. So f x of x is nothing but 2 into, instead of x you will substitute this 1 by 2. Okay, plus 2 divided by 3. So 2 and 2 will get cancelled. So 2 plus 1 is 3 by 3, which is equal to 1. Okay, so this is your denominator part. So while substituting in this equation, your probability of y given x is equal to half is nothing but, your numerator part is 1 by 3 into x plus y. This is the probability, joint probability distribution function. Okay, and denominator is nothing but 1. Okay, likewise you have to find for the fourth subdivision. Your fourth subdivision is nothing but the conditional density function of x given y equal to 1. So x given y is equal to 1. So how do you write this? The numerator part would be f of x comma y, and the denominator part would be fy of y equal to 1. Okay, so fy of y equal to 1 is nothing but, in this equation, that is in this equation you have to substitute y is equal to 1. So it will be 1 by 3 into 1 by 2 plus 1. So it is 1 by 3 into, so half plus 1, which is nothing but 3 by 2. So 3 and 3 will get cancelled. So you will have 1 by 2. Okay, so now substituting in the equation, in this equation you will get 1 by 3 into x plus y, and the denominator would be 1 by 2. Or you can write it as 2 by 3 into x plus y. Okay, next we have to check whether x and y are independent. So in order to check whether x and y are independent, we have to find whether f of x comma y is equal to fx of x into fy of y. If both are equal, then it is called they are independent. So f of x comma y is nothing but 1 by 3 into x plus y, and fx of x is nothing but 2x plus 2 divided by 3 into 1 by 3 into 1 by 2 plus y. So on solving both the sides, there is no chance of both to be equal. They are not equal, so they are not independent.